In this video, we're going to look at ways that we can synthesize carboxylic acids. And we've already seen some ways that we can make carboxylic acids, and I'm going to do a little review of some of the reactions, actually all of the reactions, and then I'll show you one little twist of a reaction and then a new way of making carboxylic acids. So one of the first reactions that we learned is oxidation of primary alcohols. And of course, we can also oxidize aldehydes to carboxylic acids. So if I take a primary alcohol and I treat it with dichromic acid, so sodium dichromate, sulfuric acid, water, and heat, this oxidizes it completely to carboxylic acid. We've already seen this reaction, and there are actually a myriad of ways that of reagents that we could use to oxidize primary alcohols to carboxylic acids. We could use nitric acid. We could use potassium permanganate is also a very good oxidizing agent. We could even use ruthenium tetroxide to oxidize it. So any number of these reagents are going to do the same thing. They oxidize primary alcohols to carboxylic acids. Now likewise, we could take an aldehyde and we can oxidize it using the same reagents. So here I'm showing chromic acid, right? Just to, instead of writing all the sodium dichromate, sulfuric acid, water, I could just write chromic acid, H2CrO4, and water. Does the same thing, just understand that we typically can't buy that. We have to make that in situ from the sodium dichromate. And notice it gives me the same results. Again, I could use nitric acid, potassium permanganate, and so on to get the same results. So that's one of the reactions that we've already seen before, oxidation of primary alcohols and oxidation of aldehydes. Another reaction that we have looked at from last semester was the ozonolysis of alkenes followed by oxidative workup. So if I take an alkene and a di-substituted alkene and I treat it with ozone, I get an ozonide that's produced from that. And most of the time, if I take that ozonide and I work it up under reductive conditions, like dimethyl sulfide, for example, I form aldehydes. But if I work it up in oxidative conditions, so I'm using hydrogen peroxide in water, the result is I get 2 carboxylic acids. You can look in section 11.6 to kind of review that chemistry if you need to. So another reaction that we have talked about this semester is oxidation of alkylbenzenes. If I take an alkylbenzene and treat it with potassium permanganate, I oxidize that R group all the way to benzoic acid. Remember that the conditions of this, that R group has to have a benzylic hydrogen in order for oxidation to take place. And last reaction that we've kind of seen, and this is where I'm putting a new little spin on it, is what's called the oxidative cleavage of an alkene. So again, if I take a di-substituted alkene and I treat it with potassium permanganate, in the presence of a crown ether called 18 crown 6 in benzene, and then work it up in acidic conditions, I can generate 2 carboxylic acids. So the result is identical to that of ozonolysis followed by oxidative workup. Now, you should be going, wait a second, haven't I seen something like this before? And you certainly have. In the first semester, we saw that potassium permanganate will oxidize alkenes, but generally they produce diols. However, when I dissolve everything up in benzene with 18 crown 6, the permanganate ion is actually more reactive, and it further oxidizes that that carbon-carbon pi bond to produce carboxylic acid. So this is a little tweak on a reaction that we've already seen. You know, remember, if I take an alkene and treat it with potassium permanganate, I get vicinal diols. When I take an alkene and treat it with potassium permanganate in the presence of 18 crown 6 in benzene, I get carboxylic acids. All right, so now the new reaction. The new reaction actually involves Grignards. So one of the easiest ways of making carboxylic acids is to treat Grignard reagents with carbon dioxide. And we get carbon dioxide, as you should know by now, from dry ice, right? Dry ice is carbon dioxide. So if I take a Grignard reagent and I simply add dry ice to it, I can make carboxylic acids. So the Grignard, a Grignard, reacts with CO2 and it attacks the carbonyl and displaces a carbon-oxygen bond. And the result is I get a carboxylate. And so when I acidify that, the carboxylate gets protonated, and the result is a carboxylic acid. This should look familiar to you because you've seen something like this in a post-lab analysis question in your lab procedure. So if I take an alkyl halide, treat it with magnesium, here I'm taking an alkyl bromide, treating it with magnesium and forming my Grignard. I then take that Grignard and I add dry ice. Dry ice happens to be at minus 12 degrees Celsius, and then I further acidify that solution and I can make my carboxylic acid. Brilliant, easy way of making carboxylic acids. And notice, since we can make Grignards from essentially any alkyl halide or aryl halide, we can make virtually any carboxylic acid that we want to. So it's a great way of making carboxylic acids, and it's something that you should definitely pay attention to.